Hi, hello, welcome everyone. So far we have seen beam singly reinforced sections theory, and we have solved some 10 small, some 5, 7, 6 problems. I think so. I didn't count it. So I will continue in similar way. We will solve some additional problems to learn better singly reinforced section. That will help us to go through the next section, doubly reinforced sections. Okay, from this section all the videos will be 15 minutes. Okay, so to make it easy for the size for you to download and also for you to have a quick refresh, only I hope you can consider it easily for 15 minutes then 40 minutes. Okay, so next so if you have any doubt, all those formulas, everything you should have in your paper, in your hand, all those formulas we have noted earlier, unless you will never understand. Okay, so go through previous section videos to have a clear cut idea of what we are going to see. So the next problem, so this is a design problem. They are asking you to design and give you the beam. Design means I already told you, we have to determine the, it is a singly reinforced section, we have to determine how much steel required. Okay, since most of the cases they will give you the width and depth. Okay, so here the given depth, width is 400 mm, given depth, overall depth is 800 mm, the beam 800 mm is quite large, and effective cover is 50 mm. So effective cover 50 mm means, I hope you know what is effective cover. It is the distance between the lowermost end of the beam to the center of the reinforcement. It is 50 mm, and it has to be designed for working moment 200 kilonewton meter. They have given using M20 and Fe415. That is standard. Usually all the residential building across India will be using M20 and Fe415. And also they are asking state whether the section is under reinforced or over reinforced section. Okay, so it should be there. Sorry for that. So given, they have given B, D. It's very simple, quite a simple. Whenever there is an RCC problem, you know there are only 3 formulas. Anything, whatever they can ask in questions, left to right, right to left, anything they can ask, it will come to a formulas, only 2 or 3 formulas. Okay, so it is always better to write a given. So clearly they have given B, D bending moment. So they are asking your beam has to resist 200 kilonewton meter. 200 kilonewton meter is a quite large bending moment. If you say for a residential building, it's very quite large. That's why they have given a depth 800 mm. So this is, I'm telling you based on practical experience, 200 is a very big number. Okay, so for a residential building, okay, maybe this is for some other purpose, commercial building or long very lengthy beam. Okay, so M20 Fe415 they have given. They are asking, first thing they are asking whether reinforced or over reinforced section. This we can determine based on 2 cases. One is based on M, one is based on MU limit. I will show you how. So step 1, check whether the section is first under or over reinforced, so that which equation you will use for calculating the AST. Okay, so we know the standard formula for MU limit, maximum bending moment, how much your beam can take based on FCK, XU max, B and D. Okay, you substitute everything they have given, 0.36, 20, 0.48 into 750 they have given. I think 750 is because of 800 minus 50. Understood, right? There's a small d, it is an effective depth. So 800 minus 50 is 750. 750 into 400. So overall, if you substitute everything, you will get 620 kilonewton meter. So if you substitute this one, so if you substitute all these values, 0.36 everything, you will get 620 kilonewton meter. Okay, so but what is the working moment? They have given 200. If you substitute the standard load factor 1.5, the maximum bending moment your beam should be designed is for 300 kilonewton meter. So so if you see the given bending moment is 1.5 into 200, that 1.5 I told you. So 300 is far less than the maximum moment the beam section what they have given can take. Maximum they can take up to 620. Okay, that is the limit for the balancer section to have a standard at a time failure. So the given section is obviously under reinforced section. We can design it as under reinforced because the given moment is only 300 for the given size. Remember that for the given size the beam is, the bending moment is under reinforced section, because I told you, right, 800 is quite large, 750 mm is. So step 2, for step 1 we have determined it is under reinforced section. Step 2, you can pause the video and then note one by one and then you can listen. Okay, or you can solve yourself. From now it is very easy. Now you know under reinforced section. To solve under reinforced section you have a formula. First you see the step 3, you know the formula, 0.87 Fi AST into D minus 0.42 into XU. You know this formula. Fi is given, AST you have to determine, MU is given, D is given, you don't know XU. So to determine XU there is a step 2. Find the XU from the compression formula. because 0.36 FCK B into XU, there is a formula. You have FCK is given, B is given, MU is given, everything is given. So you can easily determine XU. Bring everything, substitute everything here. Find the XU, the maximum neutral X 151. Substitute back here. You will get the area of the steel. Okay. I hope it is very simple. First step 1, determine whether it is under reinforced or over reinforced. Determine the neutral axis. Put in the formula. You will get the AIST required. Okay. So you can pause it and you can understand this problem. Next, I wish to go to little difficult problem. Okay, it is IIT Bombay GATE 2005 question. So they are asking you. I hope I wish to revise you for 30 seconds. I will go back to very previous slide, long back. I hope you remember this figure. Okay, so I hope you remember this figure. In this figure, you can see there is a square, there is a parabola section. And I hope you can go to the previous slide to understand. I have stressed more on this topic. So this is a concrete stress strain graph. Okay, stress graph. Okay, so in this they have in GATE 2005 they asked you to change something. Instead of this parabola, there is a parabola shape at the, you can see the right side figure bottom, there is a parabola shape. So they are asking you to make it as a straight line, linear line instead of a parabola. Okay, that's the difference. I will go back to the question. I will make it clear for you. So if you see, the question is, they are asking you to assume a straight line instead of a parabola for a stress strain curve of a concrete as follows. We are going to see that, and partial safety factor 1. So far we were using partial safety factor is 1.5 for the concrete, and this is the assumption. Okay, with this assumption the total formula so far you are using this 0.36 FCK will change. How this 0.36 FCK came? Because of we got 0.45 FCK. From there we got this 0.36 FCK. I hope you remember how you got that 0.45 FCK. We divided 0.67 FCK divided by 1.5 to get that 0.45 FCK, and then we did some area everything corrections, and then we got this 0.36 FCK. Okay, you can rewind and listen. There was FCK, then for slenderness reason we can use only 0.67 FCK, then we divided by 1.5 to get the 0.45 FCK. From that 0.45 FCK, because of the parabola shape everything, we got 0.36 FCK as a stress value. Okay, now they are asking you, don't assume parabola, assume straight line. First correction. Then they are asking, assume 1 for the concrete, don't assume 1.5. Okay, so we are going to do this 2 correction, and then we are going to have a new formula for determining the neutral axis and for the mu value. Okay, but the question they are asking is to find only the neutral axis. So use this correction, determine the formula, and then they have given a rectangular beam under reinforced concrete section. They have given 250 mm width, 450 mm depth is reinforced with 3 bars of Fe 4 and 5 bars each of 20 mm diameter. FCK is M20. So they are asking, because of this new theory, where the neutral axis will be, and the question number 14 is, as per IS 456 for the same beam, where will be the neutral axis and what is the difference? Quite an interesting problem. Unless you know the theory of singly reinforced very clearly, you can never answer this question. Okay, from the derivation, step 1, step 2, how we derived it. Okay, so I will show you very simply. So this is what they were telling. You can see the right side figure. This is what they were telling. They are asking you to take 0.67 FCK itself. Okay, you can go back to the derivation and see we have a 0.45 FCK there, because 0.67 divided by 1.5 we used. Here it is only directly 0.67 FCK, and then they have assumed a straight line. You can see instead of parabola at the bottom 4 by 7 of FCK, they have assumed a straight line. This is the correction they told you. So how to derive this formula now? We know always force is stress into area. So we are dividing into 2 sections. You can see C equal to C1 plus C2. C1 is the rectangular portion, C2 is the triangular portion. For C1 is a force is stress into area. What is stress into area? So 0.67 of FCK is stress into area is 3 by 7 of XU. How you got this 3 by 7 of XU? I wish to tell you. Give me a second. Yeah. So 3 by 7 of XU, 4 by 7 of XU, you got it from the derivation earlier by similar strain. You remember the step 1 in deriving the equation was using a similar triangle to get the value of this 3 by 7 XU, 4 by 7 XU. You can go back to the video, I think 2 or 3, to the chapter 3. Initially I have derived this 3 by 7 XU, 4 by 7 XU, how it came. You can refer there and come back. So they used this 0.67 FCK, length into breadth as a point, stress into area, 3 by 7 of XU they have used, plus half BH is the area, half 0.67 FCK into 4 by 7 of XU, stress into area. Okay. So you do the corrections. Now you are getting the value. You are getting a value of 0.478 FCK B into XU. Okay, so now you can see the number is changed. It is 0.478 FCK into B into XU is always an area. B is the width of the beam, XU is the overall neutral axis. So stress into area, you got the stress value is 0.478 FCK. Initially we were getting, if it is a parabola, we were getting 0.36 FCK. I hope you remember that. Okay, there is a quite large difference of 0.17. Okay, now you got the compression C value. Now we know C equal to T, obviously. Okay, so now you are coming back to the problem. Now you got the theory derived, C equal to 0.47 FCK 478. So you just substitute C equal to T. You know this is the C value for this theory. T will be the same, 0.87 Fy into AST. This is stress into area again. They never changed anything in the question related to steel or tension side. So they only changed it related to concrete compression. Okay. So 0.87 Fy AST. You equate both, everything is given. FCK is 20, XU is 250. No, XU we have to find. B is 250, 0.87, Fy is 4 and 5, AST is pi by 4 into 20 square. I think 4 bars. I think I should. Okay. So it is pi by 4 20 square into 3. You substitute everything given. So you will get the neutral axis is at 142 mm. Okay. I think quite simple. It is self-explanatory. Only the thing is you have to derive the equation. Next, if you see. Give me a second. So the next question is the answer 14. They are asking you to calculate as per the IS 456. IS 456 we know the formula, it is 0.36 FCK B into X equal to same similar formula. The only the number 0.36 is changing. Here it was in previous slide it was 0.478. Here it is 0.36. You substitute everything, you will get an answer of 189 mm. So the neutral axis is, if you are calculating based on parabola and applying a factor of safety, the neutral axis at 189 mm, and if you are using the theory what they are asking in the question, it is 142 mm. So the difference when you are using a different theory is 46 mm. Okay, that is your second question answer. So next question. So this will be the final question in singly reinforced section. You can pause it and solve those things. If you have any doubt, I have given an email ID here below. You can ask for the doubts. So next question, the final question in singly reinforced question. It's a GATE 2007 question from IIT Kharagpur. So again they are asking for similar theory change. Okay. So in designing of a beam for the limit state of collapse in the flexure, they are asking let the maximum strain in the concrete is limited to 0.0027. I hope you remember. I have explained clearly the concrete breaks at 0. The maximum strain the concrete can take before it fails. Okay, is 0.0035. They are asking you to assume 0.0027. Okay, for this situation, they changed the strain value. So if they are changing the strain value, it's gonna change everything because the step 1 of x1 and x2, the 3/7, 4/7 of xu will change. From that, the total equation will be changing. Okay. So for this situation, they have given again a rectangular beam of width 300 mm, depth 450 mm, AST 2000 mm square. They have given, they didn't give the bar, they have given directly the AST values, and FCK value 30 MPa and FY value 250 MPa. Okay, so they are asking what if I am changing the strain value, what will be the depth of neutral axis from the compression fiber, means from the top. So they are asking at what is the maximum compressive force. See the question 16, they are asking at failure, means the maximum compression force, how much kilonewton the beam can take before failure. That's what they are asking in question 16. Okay, so exactly similar question like GATE 2005, but here they are changing the strain values. I'll show you how to solve. So again, so they have changed the strain value. You can see the right side figure. They have changed it from 0.0035 to 0.0027. So it's quite simple. So if you go to the derivation back, I am doing the same thing here. I am taking a similar triangle. Step 1. So opposite side is 0.0027 divided by xu will be equal to 0.002 divided by x1. I will get the value for x1 and x1 plus x2 equal to xu. So I will get the value for x2 also. So that is the step 1. Okay. So if I know the value of x1 and x2, so I will substitute again the similar procedure, C equal to C1 plus C2. This is a parabolic area again as earlier. So C1 equal to stress into area, it's 0.45 FCK into that x1 value plus 2 by 3 of BH, right? So I have taken the B common. You can see that outside. B is common outside. So you can bring it's nothing but stress into area. Okay. So I will explain. C equal to C1 plus C2. What is C1? C1 is the force acting on the rectangular portion. How much force is? Force is nothing but stress into area. Stress is 0.45 FCK. Area is B into 7 by 27 of XU, because x2 is 7 by 27 of XU, plus C2. You see the please see the figure. C2 is that parabolic portion. C2 is nothing but a force. force is stress into area. Stress is again 0.45 FCK into 2 by 3 of B gauge, 2 by 3 of B into 20 by 27 into XU. That's what I have written. Solve this one, you will have the value of 0.33 FCK B into XU. Initially we had 0.36. Now because of the reduced strain value, the stress force also acting will be reduced. It is 0.33 FCK B into XU. So now you got the formula. Now it's very easy. So now you substitute that formula, C equal to T. They have given everything. So you substitute that 0.338830 into FCK is 30. They have given in the question. B is 300 into XU equal to 0.87 Fi 415 into 2000. So substitute everything. You will get a XU value as 142.6 mm. Okay. So you can pass it. It's very simple. Just a formula substitution. Only thing is the step 1 and step 2 you should be very clear. So that step 3 is very easy. This is an answer for 15th question. And question number 16 is very simple. They are asking just the C value. Okay, C value is quite simple, right? You know the XU value. Just substitute back the XU values because stress into area is the C value. Stress is 0.33 FCK you have calculated. Area is B into XU. You know everything. XU you know from the previous answer. It is 142.6 mm. Substitute here. You will get the 434.88 kilonewton. Okay. So far I have answered some 3 questions more from the previous 7-8 problems. I hope I made you clear how to calculate the maximum bending moment for a singly reinforced section, how to analyze a beam. If somebody gives you the beam dimension, if it is a singly reinforced, how to calculate the maximum moment it can take, and how to calculate the neutral axis, where is the neutral axis, where is the maximum neutral axis, and how to design the beam. I have showed 1 or 2 problems in how to design a beam, and if finally I have even showed some examples if they change the total question theory itself. So how to answer that question. Okay, so then you have to come from the step 1 to step 3 like we solved the last previous problems. Okay, I think I made you clear about singly reinforced sections. If you have any doubt you can ask me, or if you want any topic to be stressed again you can mail me, or I can answer your doubts. So this closes the topic of singly reinforced section. With the knowledge we gained in this chapter, we are moving towards the doubly reinforced section from the next session. Thank you.